October 17th, 1989. Santa Cruz, California. It's an easygoing town nestled beneath the mountains of the Northern California coast. A visitor once called it an outpost of Eden. But the San Andreas Fault curves through these mountains, pushing them up with earthquakes. Another is due, according to scientists. In a new kind of forecast, they offer probabilities as high as 85% over the next 30 years. On this day, underneath a mountain called Loma Prieta, probability became reality.
Leadership. It's a quality, it's much more similar to the Mexican three idea.
At 5:04 p.m., Latin American Studies 1 was underway at UC Santa Cruz.
And they have a candidate who's very strong and is fighting with us for second place.
With video cameras everywhere, this was the most visible earthquake ever.
So the Oakland A's take.
Hey, what, we're having an earthquake.
In downtown Santa Cruz, the shaking was over in 20 seconds.
And all of a sudden it started to shake a little bit, and then it starts to warm.
Get off the avenue. You can't expect further aftershocks. There will be more building collapses.
Most of the old masonry buildings were beyond repair. A plan to reinforce them had never been agreed upon. People were injured. Some were missing. Volunteers put themselves at risk from aftershocks. With power out and telephones overloaded, the town was on its own. Like most of San Francisco, Candlestick Park withstood the impact. The stadium was built on bedrock. It had recently been reinforced.
Ladies and gentlemen, power has been interrupted. The game has been called. Can you please leave the stadium in an orderly manner?
Other structures fared less well. The Bay Bridge was built to withstand such an event. But that was in the 30s, before much was known about earthquake engineering. One stranded driver made a video record.
This is the crack down there. They sent us down here, surprisingly, in the wrong direction. There's another car. Gosh! Thomas, we need to go down there and help.
Heading south onto the Nimitz. That is completely collapsed.
The worst disaster lay across the bay in Oakland. A section of road atop the two-level Nimitz freeway collapsed, crushing 53 cars below.
No, he's alive. He's trapped in there.
No, you're in your truck.
He heard me and then he parked aside.
Your truck is upside down.
Man, this is over.
We need something to pry the door.
And he's got the pry the door open.
Screaming and just begging us to get him out. We tried everything.
The freeway was built in the 1950s before concrete structures were designed to be flexible. The road was slated for reinforcement.
There's a gas leak. Let's go. Turn around and go that way.
In the Marina District, the soft landfill caused houses to topple and gas and water mains to break. A lethal combination.
Right now we have a major fire burning in San Francisco's Marina District. A building there collapsed and burst into flames as another building across the way from it on the northeast corner of Beach.
As emergency services worked through the night, scientists at the United States Geological Survey began to assess what had happened deep down in the earth. The unspoken question, was this the earthquake that had been forecast?
Pretty quickly we knew where the earthquake was, and as soon as we knew where the epicenter was, honest, we all knew what had happened. We all knew it had been precisely that segment we had been concerned about, and that long-term forecast had been fulfilled.
The apparent success of the forecast was affirmation for a new approach to earthquake alerts. Long-term forecasting is an attempt to give communities years or decades to prepare. But scientists also continue to search for the means to predict earthquakes, so they can issue short-term warnings in the days or hours before an event.
We came closer to predicting this earthquake than we've ever come before. However, that's much less than half a loaf. Our job is to predict earthquakes and save lives, and clearly we didn't predict it in any sense that could have saved any of the people that were killed in the collapse of buildings or freeways.
Short-term prediction remains an unfulfilled goal of earthquake studies, so scientists are on the lookout for some kind of warning event. They call them precursors. For example, small earthquakes are common before a large one. But these foreshocks are hard to recognize, and this time there had been none. But something else had preceded this earthquake. Near a town called Corralitos, only 3 miles from the epicenter, an experiment was underway that had nothing whatsoever to do with earthquakes. An antenna had been installed to monitor naturally occurring radio waves, part of a communication study for the Navy. Anthony Fraser Smith, a Stanford physicist, found that unusual low-frequency radio waves had preceded the earthquake. He wondered whether the squeezing of the earth before the fault ruptured had produced them.
3 hours before the earthquake, the activity went up to a level where you don't normally see it at all. And then the earthquake struck, and then we lost electric power, and we didn't have any more measurements. We've been recording at this Corralitos site for 2 years. We haven't seen anything like these big signals coming through.
If Fraser Smith's observations could be repeated, perhaps next time there would be a warning. But he faced a paradox all too familiar to earthquake scientists. In order to repeat his experiment, he would need to locate his antenna near the site of another earthquake. He would have to predict an earthquake to test his experiment in earthquake prediction. Often, earthquakes leave physical evidence, but even so, they remain elusive. To recognize patterns, geologists need to compare dozens of events. Yet few here now will be alive when the next earthquake takes place here. Earthquakes remain the most difficult of all natural phenomena to understand, much less predict. The recent achievements in forecasting are the result of efforts that have been ongoing for over 2 centuries, all inevitably pushed ahead by the devastation of another earthquake. The first important understanding of these events followed one of the greatest cataclysms of recorded history. Lisbon was one of the richest of European capitals, and during this time of Inquisition, earthquakes were an indication of divine wrath. On All Saints'